Good afternoon, students. How are you all? Hello, Shillong Center. So those who are present, just give me a response. Those who are present right now. Okay. So far in the similar triangle, uh, uh, we have done so many concepts like the Thales theorem we have done, and we have done the different similarity concept like angle similarity, in which if the two angles of a triangle are equal, those two triangles are similar. We have also done side similarity, and third one is side angle side similarity. And in the last class, based on these three similarities, we have done some of the questions. So today we will practice some of the questions on these similarities, then we will move on to the next part of the similarity related to the area of the triangle, how area of the similar triangles are related to each other. So let's start with one question. Suppose it is given, this is the diagram given, and it says angle ADE is equal to angle B. AD is equal to 3.8, AE is equal to 3.6, BE is equal to 2.1, and BC is equal to 4.2. We have to find DE. And this, you can see in the diagram, this angle C is 90 degree. So this angle C is equal to 90 degree. ADE and angle B. ADE is this angle, this red one, and this is B. Good afternoon, Senapati College. How are you? So these two angles are equal. One of the angle is 90 degree, you can see, and these are the measurements given, like AD, AE, BE, BC. We have to figure out DE. So try to prove, first of all decide which triangle you will prove similar, and after proving the triangles are similar, try to relate the sides. Good evening, Itanagar. How are you? Try this question. First of all, figure out, like, you have to find DE. DE side lies in which of the triangle? Which of the triangle you have to take to prove the similarity? Yes, Shillong, you have to do it in that way. First of all, prove them these are similar, then proceed. And to prove the triangles are similar, you can use any of the three concepts. Either you can use angle angle, you can use side side side, or you can use side angle side. Sisipur, solve this question fast. If there any difficulty you are finding, please let me know. Yes, Sisipur, correct answer. No, Shillong, your answer is somewhat correct, but not accurate. The decimal part is not right. Itanagar, what about you? What's the answer you are getting? See, first of all, you all have to do, you have to prove the triangles are similar. And first of all, you have to figure out, we have finding DE. DE is this one side. So it is the part of the triangle AED, and other triangle which you can see is ABC. So you have to prove in triangle AED and triangle ABC. Since we have to prove that similar, so we will look for the side. There is no information regarding side is given, but information regarding angle is given. So in AED and ABC we can see angle A is equal to angle A. This is common. And second, the angle which is given, angle ADE is equal to angle ABC. This is given. Now after this is two angles are equal, so by angle similarity, we can show that these two triangles are similar. Now the important thing is how we will write the name. The name of the first triangle you can write in any order, whatever you want. Like let's say I have written AED. Now the name of the second triangle will be with respect to the first one. Like I have used the letter A over here first, and this angle A is also equal to angle A. So name of the second triangle ABC will also start with A. Now it is E over here, and E we don't know, we have not information about E, but in AED we know angle D, and angle D is equal to angle B. So D is in the last, so here B will be in the last. So it will be ACB. So like A and A correspond, D and B will correspond. Similarly, angle E and angle C will be equal. After writing this notation of similarity, now we can use the ratio of the sides. So we can write the ratio of the side as AE upon AC, the starting first two from here and first two from this triangle, is equal to AD upon AB, and that is equal to ED upon CB. This is the relation we can write after proving them similar. Now look at this, what we have to find? We have to find DE. So this is DE over here. Now with DE we have CB, and we want the value, we know the value of BC also. AD is there, we know the value for AD. AB is there. Now we don't know the value for AB, but we can see AB is made up of AE and BE, and AE and BE both are known. So it means we will take this relationship. So we can write AD, in place of AD we can put 3.8. In place of AB, AB is nothing but AE plus BE, so we have to add both of them. So 3.6 plus 2.1, which is 5.7, is equal to ED over BC. BC is 4.2. So this will be cancelled out by 1.9, 2 times. This is 3 times, and 3 1.4 times, and 1.4 into 2. So ED will be equal to 2.8 centimeter. So this is the answer. All of you are getting it? 2.8. Itanagar, Tetso, Senapati, Shillong. Is this clear to all of you? Other centers, is this clear? Okay, then that's great. So let's move on to the next question. Now this question is a little bit of proving type. So diagram is not there with the statement, you have to draw the diagram yourself. It says through the midpoint M of side CD of parallelogram ABCD, A very good question. It was in the board examination. Through the midpoint M of side CD of parallelogram ABCD, the line BM is drawn intersecting AC in L and AD produced in E. AD produced in E means when we will extend side AD, that will intersect at E. So we have to prove that EL is equal to twice of BL. When you are done, just let me know that you have completed this. We have to prove that EL is equal to twice of BL. That's great, Shillong. What about the other students? Have you done this? I'm drawing the diagram for all you people, those who have not understood, since it is not the part of the question. Through the midpoint M of side CD of parallelogram ABCD. So you can draw a parallelogram, and you should remember the properties of the parallelogram while solving this. So this is the parallelogram ABCD. Through midpoint M of side CD. So this is CD, this is M over here. M is the midpoint. The line BM is drawn intersecting AC in L. So this BM. So BM is drawn, and this line intersect AC. It means we have to join AC also in L. So this intersection point is L. And AD produced in E. And when we extend AD, it will intersect AD produced in E. So this is the point. So now we have to prove that EL is equal to, this side EL is equal to twice of BL. So again, we will get that by proving that the triangles are similar. Because EL is equal to twice of BL, it means EL upon BL is equal to 2 upon 1. The ratio of the side basically we have to figure out. And ratio of side we will get by equating, by proving the triangles are similar. Now how you will do this? First of all, you know that in this triangle, in triangle DME and triangle BMC, these two triangles we can see, DME and BMC. In these two triangles we know that this M is the midpoint. So we can say DM is equal to CM, right? Second thing, we know that these two angles are all vertically opposite angle. Angle DME is equal to angle CMB. These are vertically opposite angle. Similarly, the third thing, since it is a parallelogram, so sides are parallel. If sides are parallel, then alternate interior angles are equal. So we can say that angle MCB, this angle, is equal to angle MDE. So we can say over here, this is angle, then side, then angle. So by angle side angle congruency, these two triangles are congruent. By ASA, triangle DME is congruent to triangle CMB, DME and CMB. These two are congruent. If these two triangles are congruent, therefore, by CPCT, we can say that these two sides, the BC is equal to DE. By CPCT, we can say that BC is equal to DE. And but we also know that in parallelogram, the opposite sides are equal. So BC is also equal to AD. So we can say BC is equal to DE, we have figured out, but this BC is also equal to AD, right? So this is, let's say this is first equation, this is second equation. We can find the relationship between these two. If we add both of them, first plus second, the left hand side and left hand side will get add. So this BC plus BC, that will become twice of BC, and DE plus AD, that will become AE. This is the relationship which we are getting. So this is the relationship we are getting between BC and AE. Now the thing which we have to prove is BL and LE. Now you can see, if we prove, this is the relation of twice. If we prove the two triangles, the required triangles are similar, then the ratio of all the sides would be equal. So now what we have to do, we have to think about triangle, these two triangles, ALE and triangle CLB. if we can prove that these two triangles are similar, then ratio of all the sides would be equal. And we have already known that BC and AE are a relationship is of twice. So we can also say BL and LE will also be twice. So how we can prove that these two triangles are similar? Again, the very basic concept is of the angle-angle similarity. So you can see that these two angles, these are vertically opposite. The name is angle BLC is equal to angle ELA. Reason is vertically opposite angle. Second angle we can take, since it is a parallelogram, so alternate interior angles are equal because AC is nothing but the diagonal. So we can take angle LCB is equal to angle LAE. This is alternate interior angle. So using the angle-angle similarity, so we can say by angle-angle similarity, triangle ALE is similar to, now naming is important. We are starting with A, so its name should start with C because A and C are vertically alternate interior angle, so it will be CLB. So if these are similar, then we can relate it like the sides. The sides will be which Itanagar? Itanagar, which one? Which one you are saying? Alternate angle. LCB and LAE. These are alternate interior angle. So we can say that AL and upon CL, that is equal to AE upon CB, that is equal to LE upon LB. Now since we were focusing on EL and BL, this part, and we know BC and AE, so this is the equality which we have to use. So we know that AE is equal to twice of BC. So in place of AE we can write twice of BC over BC is equal to LE upon LB. BC and BC will get cancelled out. So from here we can say EL is equal to twice of BL. CPCT in the 9th class, CCPur, when you are studying the congruent triangle, you must have seen the word written CPCT. It known as corresponding parts of congruent triangles. When we have proved that two triangles are congruent, then all the corresponding parts will be equal. So this is the standard short form, corresponding parts of congruent triangles. This is the full form. Corresponding parts of congruent triangle. Sorry. We will always use this one while we are proving the triangles as congruent. If we have proved the triangles as congruent by any of the congruency, after that to relate the remaining parts, we will use this short notation CPCT. Is this question clear to all of you? CCPur, Shillong, Itanagar, Tetso College. Is this clear to all of you? Any doubt in this question? If you don't have any doubt, we can proceed further. Just let me know. Senapati, what about you? Is this clear? Okay, so let's move on forward. Now, like we know, till now we know that if two triangles are similar, then the ratio of the corresponding sides is equal. There is one more property of the similar triangle is that we have three things like medians, angle bisector, altitudes. So, if two triangles are similar, then ratio of the sides are equal as well as the ratio of the corresponding median and corresponding altitude and corresponding angle bisector, that is also equal. So next question is based on that concept, like if it is given that two triangles are similar, we have to show that the ratio of the side is also equal to the ratio of the corresponding median, angle bisector and altitudes. So three types of questions are there. So I am doing first one for you, rest two you can do in the same way. So the statement goes like this. It is a proving type question basically. It says, if two triangles are equiangular, equiangular means which have the same angle, and if they are having same angle, it means those two triangles are similar. So if two triangles are equiangular, prove that the ratio of corresponding sides is same as ratio of corresponding median. So in place of median, it can be altitude, it can be angle bisector also. So, and now first of all, what is median? Median is a line segment which joins the midpoint of the side to the opposite vertex. Like if we have this triangle ABC, so if D is the midpoint of BC, then line joining the vertex A to D, this AD is known as the median. Line joining the midpoint of the side to the opposite vertex, that is known as median. So this AD is the median. So in this question, what we have to do, it says there are two triangles which are equiangular. So equiangular triangles we can take, and we know if the triangles are equiangular, it means all the angles are equal, and if all the angles are equal, the triangles are already similar. So these two triangles are there, triangle ABC and triangle DEF. Now this is equiangular, so we can say triangle ABC is similar to triangle DEF, or we can say angle A is equal to angle D, angle B is equal to angle E, and angle C is equal to angle F. This thing is given to us, and let us draw the median of these triangles. So corresponding median means like from angle A I am drawing, so in that triangle also from angle D I have to draw. So let's say name this one as P and this one as Q. So AP and DQ are the medians of these two triangles. So what we have to prove over here, to prove side. Now ratio of any side you can take AB upon DE, you can take BC upon EF, you can take, or DF upon AC you can take. So ratio of any side, so let's say BC over EF. This ratio of side is equal to the ratio of the corresponding Senapati, equiangular. Equiangular means which are of same angle, equal angles. Like we use the word equilateral. Equilateral means which are of equal side. Similarly, equiangular means which are of equal angles. That is the meaning of equiangular. So this thing we have to prove, like BC over EF, that is equal to AP over DQ. So ratio of the side is also equal to the, these two triangles are already similar. So ratio of the side, corresponding side, is also equal to the ratio of the corresponding median. That we have to prove. Got it, Senapati? What is the meaning of equiangular? Now, how we will proceed in this one? Since we want the ratio AP is also equal to DQ, so we will have to prove those two triangles are similar which contains AP and DQ. Now we know the AP side is in triangle ABP, and yes, the meaning is equal angle, right? So the triangle ABP and DEQ, these two triangles are there. In these two triangles, AP and DQ are there. So our aim is to be how we can prove that these two triangles are similar. If we can prove these two triangles are similar, then the ratio would already be equal. So let us see. So proof. Now we already know that triangle ABC is similar to triangle DEF. We also already know. So we can say this AB over DE, that is equal to BC over EF. This thing we already know. Now we also know that AP and DQ are the medians. If this is the median, it means this point P is the midpoint and Q is also the midpoint. If this is the midpoint, it means BP is equal to PC and EQ is equal to QF. So we can also write this thing as in place of BC we can write twice of BP, and this EF we can written as twice of EQ. So this 2 and 2 will get cancelled out. So AB over DE, that is equal to BP over EQ. This ratio we know. Now what we can take? Now these two triangles we can take, the left hand side triangles of both of them, ABP and DEQ. ABP and triangle DEQ, these two triangles. So in these two triangles we know that AB over DE, that is equal to BP over EQ, and the angle B and angle E are already equal. It is given in the question itself. So now what we can see over here, these two sides are of equal ratio, and this angle B is equal to angle E. So when included angle is equal and the other two sides are in the same ratio, we can use the similarity concept of side angle side similarity. Therefore, by side angle side similarity, triangle ABP is similar to triangle DEQ. These are similar, right? If ABP is similar to DEQ, then we can also say that the ratio of the corresponding sides would be equal. So we can say AB over DE, that would be equal to AP over DQ. and this AP over DQ is nothing but that median, and AB over DE, and the rest of the things we can also say AB over DE is also equal to BC over EF, and this is also equal to AC over DF. So main thing is that these are the ratio of the sides. These ratio of the sides are also equal to the ratio of the corresponding median. This is the thing which we have to prove. All of you are getting this result? Ratio of the corresponding side is equal to the ratio of the corresponding median. Are you getting this, all of you? Only we have taken the sides, we have proved the ratio as same, and then we have proved those two triangles as similar, in which we have to show that the median lies. Sisipur, Itanagar, Kohima, Senapati. Is this clear? Okay, so note down the homework also, because right now I have proved that the ratio of the side is equal to the corresponding median. So what you have to do? You have to prove that the ratio of the side is also equal to the corresponding medians, altitude and angle bisector. The median I have done, you have to do this remaining part. Ratio is equal to the altitude as well as angle bisector. Altitude means when we draw a 90 degree from one vertex to the opposite side. There is no need to write AC upon DF in the solution. I have shown this, that the ratio, you can write any of the side out of these three. You can write any of the side, and any of the ratio of any of the side is equal to the ratio of the median. That is the thing we have to show. And note down the homework also, the rest of the two parts, like ratio of the side is equal to the ratio of the altitude as well as angle bisector, you have to do. Those are also valid in this one. Now the next one is the important theorem related with the area, which is area of two similar triangles. So this theorem briefly gives us about the idea how the area and the sides of the similar triangles related to each other. So this is a very important theorem. So write down the statement of the theorem. It says the ratio of area of two similar triangles is equal to the ratio of area of two similar triangles. If two triangles are similar, then the ratio of the area is equal to the ratio of square of the corresponding sides, any two corresponding side. So basically it also says that if you draw the diagram, suppose these are the two triangles ABC and DEF, and it is given these are already similar, that is given. So we can say given triangle ABC is similar to triangle DEF. Now we have to show, to prove. What we have to prove? That the ratio of area. So the notation for writing the area is AR. You have done this in the 9th class also. Area of triangle ABC upon area of triangle DEF. This is equal to the square of the ratio of any two corresponding side. Either you can take AB over DE whole square. This is also equal to AC over DF whole square. And this is also equal to BC over EF whole square. And from this point we can also add one more point. Like in the previous theorem we have shown that ratio of the any two sides is also equal to the ratio of median, altitude and angle bisector. So area also relates in that way. Ratio of area is also equal to the ratio of the square of the corresponding side and median also. Let's say median of triangle 1 and median of triangle 2. Square of the ratio of median, square of the ratio of angle bisector or altitude. So all the things will be equal. So we have to prove this thing. So are you getting it? Like what we have to do in this theorem? Now since we are relating with the area, so area of triangle you all know it is given by half into base into height. So we don't know right now what is the height of the triangle. So what we will do, we will create the height. We will draw two altitudes of this triangle. So in this triangle we can do the construction. So in this first triangle we can draw this AL as altitude and here let's say M. So we can write draw AL perpendicular to BC and DM perpendicular to EF. AL perpendicular to BC I have drawn and DM perpendicular to EF, so that we can find the area. Now we can start with the proof. Now we know that these two triangles are already similar. Triangle ABC is similar to triangle DEF. Therefore we know angle A is equal to angle D, angle B is equal to angle E, angle C is equal to angle F, and this ratio AB over DE, that is equal to AC over DF, and that is equal to BC over EF. This is the relationship we know. Now what we can do, if we take these two smaller triangles, the left hand side of the triangle, like triangle ALB and triangle DME. So ALB and DME. So triangle ALB and triangle DME. Now how we can show that these two triangles are similar also, because in both the triangles one of the angle is 90 degree by the altitude we have drawn and angle B is equal to angle E. So we can say angle B is equal to angle E. It is given angle ALB is equal to angle DME. This is by construction. So we can say that these two triangles are similar. Therefore triangle ALB is similar to triangle DME. After proving that these two triangles are similar, we can show that the ratio of the side is equal to the ratio of the altitude. So we can say AB over DE, that is equal to AL over DM. And this AB over DE, that is already equal to BC and EF, because we know that AB over DE is also equal to BC over EF. Therefore, it implies we can write BC over EF, this equal to AL over DM. I have replaced AB over DE by BC over EF. Now, when we will write the area of the triangle, so area of triangle ABC upon area of triangle DEF. So area of triangle is given by half into base into height. So half times base, or directly we can write. So half times base. So in this ABC triangle, we can see the base is BC and height is AL. So we can write BC into AL, and in that triangle the base is EF and height is DM. Now just we have proved that BC over EF is equal to AL over DM also. So we can replace this half and half will get cancelled out. So BC over EF, this AL over DM can be replaced by BC over EF again. So this will equal to BC over EF whole square. And this is the thing which you have to prove. Ratio of area of two triangles is equal to the ratio of the square of the ratio of corresponding sides. And now after proving one of the ratio is equal, so rest of the ratios are already equal, we know. Rest of all the corresponding sides, corresponding altitude, median, angle bisector, all will be equal. So this is the thing which we have to prove over here. So in the last we can write hence proved. And this is the mark, this theorem is a very important one. All of you are getting this theorem? Is this clear to all of you? So this theorem I have proved. Now note down one homework. Like I have proved the ratio is equal to the ratio of the side. You can also prove ratio of the area is equal to square of the ratio of median, altitude, angle bisector. All you can do. Like altitude we have already done. Like this is the altitude we have done. This AL and DM are the altitude. We can replace this BC by EF as AL by DM also. Now a very small question, a basic question on this theorem. Suppose if it is given triangle ABC is similar to triangle DEF, that is given to you. AB is equal to 1.2, DE is equal to 1.4. Find ratio of area of triangle ABC and triangle DEF. A very basic question based on the result of this theorem. Two triangles are similar, sides are given, find the ratio of the area. Yes, it will agar correct. Just a basic simple calculation. What about others? Those who have done the first one, you can try the second one. Yes, Isipur, that is right. Try the second one. No, Itanagar. Is this the answer for the second one you are writing? 17.5. See, in the first one, triangle ABC is similar to triangle DEF. So, ratio of area of triangle ABC. So, ratio of triangle ABC over DEF, that is nothing but AB over DE whole square. Square of the ratio of corresponding side. So, 1.2 over 1.4. If we simplify that one, that will be 6 by 7. And 6 by 7 whole square is 36 over 49. That is the answer for first one. Now, if you talk about the second one, all of you are getting different answers. It's an easy one. Why you all are getting different answers? Triangle ABC is similar to triangle DEF. Area of both of them is given. BC is given. We have to find EF. Again the relationship. Area of triangle ABC upon area of triangle DEF, the ratio of the corresponding side BC and EF, BC over EF whole square, right? Now area is given, we can put the area 9 over 16 and the value of BC is given 2.1 over EF whole square. So if it is whole square over there, we have to take the square root on the left hand side. So when you will take the square root, it will become 3 over 4 is equal to 2.1 over EF. 3 will cancel out this 2.1 0.7 times. So EF is equal to 2.8. What were you doing earlier? Like Sisipur, you are getting 37, Itanagar 17.5. And Sisipur again you are getting 2.7, then 7.84, so many different answers. Shillong, whenever it is given that find the ratio, so we don't have to calculate the answer in decimal. You have to represent your answer in the form of ratio itself, not in the form of decimal. Keep that thing in mind. Whenever it is done, find the ratio of two sides. So you have to give the answer in the form of A ratio B, like that. Don't calculate up to decimal. Okay, try this third one. Just last question, then we will take break, Kohima. Just last. In trapezium ABCD, and Kohima, you have to give the answer. You have not given any of the answer and you have just given your response for the break. Do this one. Trapezium ABCD, AB parallel to CD, AB is twice of CD, AOB area is given, COD area you have to find. Yes, Itanagar, right? Other centers, it's a easy question. Do it fast. Yes, Shillong, correct. Yes, Kohima, that is also correct. Perfect. Sisipur. No, Sisipur, this is not the right answer. See, this is given trapezium ABCD. So AB is parallel to CD and AB is twice of CD. So we can take AB in the base. And they are intersecting like this. So AOB. So this is triangle AOB and this is COD. And we know that this is a trapezium, so alternate interior angles are equal. This angle is equal to this angle and this angle is equal to this angle, vertically opposite. So we can directly say that these two triangles are similar. So if these two triangles are similar, so area of AOB divided by area of COD that is equal to the square of the ratio of corresponding sides. Corresponding sides are AB and CD. So AB over CD whole square. So from this given condition, AB over CD is nothing but 2. So 2 square is 4. So area of AOB is 84. 84 divided by area of COD, that is equal to 4. So area of COD, that is equal to 21. That's it. Getting it, Sisipur? Is this clear? Okay, now you can take a break. So we'll discuss the rest of the questions after the break. Okay, so let us continue with this one. So till now we have done the question on this area and the side of the triangle. So based on the same concept also, try one more question. It is a board examination question. It says, this is the diagram. This is triangle ABC. And this is DEF. DE parallel to BC. And AD is to DB is 5:4. Find ratio of area of triangle DEF to the area of triangle CFB. Do this one. AD is to DB, that is given. We have to find the ratio of area of DEF and CFB. First of all, think like which triangle we have to take and how we can relate the sides. And if we have to find the ratio of the area, we have to find the ratio of the side, and then we have to square it. So think in that way. सोनू समझ में आ रहा है ये? Not that easy. इतना भी नहीं है कि you just have to directly square it. Look closely. See the triangle which you have to prove the area, which you have to find the area, find the ratio of the sides of those two triangles. It's not that easy. It's easy, but not direct, like we have to just do the square. No, Itanagar, it's not like you just have to square the ratio. You have to make a little bit change in the ratio. Tamenglong Center. Go. St. Paul High School, Tamenglong, Tetso College, give your responses. You have not given any of the responses so far. Are you getting it, all these things? St. Paul High School, Tamenglong, Tetso. Sonu, can you write that question once again? Now we can do that. And Sisipur, what you have written? Okay, okay, okay. Sonu, this is your question, like find the problem from coordinate geometry, distance between a sin alpha, b cos alpha, this one? Sonu, what you can do, whatever question you are having apart from this triangle, just WhatsApp me those questions on your group. Or you can write it right now. Okay, we have to find the distance between these. Okay, rest of the students, I'm just solving one of the question from the coordinate geometry. This is the doubt of one of the student. Those who know, you can also do this and try to do the previous question. So the question is like a sin alpha minus b cos alpha. This is one of the coordinate, and minus a cos alpha b sin alpha. We have to find the distance between these two. This is the doubt of one of the student from Shillong. So a sin alpha minus b cos alpha and minus a cos alpha b sin alpha. So we all know that the distance formula is given by square root of x2 minus x1 whole square plus y2 minus y1 whole square. So we can take this a minus a cos alpha minus a sin alpha whole square plus b sin alpha minus of minus b cos alpha, that will become plus b cos alpha. This is the first step, we can put it over there. Now we can just do the squaring. So it is, we can take this minus as common in this one. So it will generally become a cos alpha plus a sin alpha whole square. And this is b sin alpha plus b cos alpha whole square. Now we can open this by a plus b whole square. This is a square plus b square plus 2ab. So it will become 2a square cos alpha sin alpha. In the same way, when we will open the second one, it will become a square, which is b square sin square alpha plus b square cos square alpha plus 2ab, 2b square sin alpha cos alpha. Now we know one identity, that sin square theta plus cos square theta is 1. So this thing, a square cos square alpha plus a square sin square alpha, if we take a square is common. So in the bracket it will be cos square alpha plus sin square alpha. Similarly, from this one we also can take b square is common. Sin square alpha plus cos square alpha. And from here we can take what we can take common from these two. We can take 2 cos alpha sin alpha we can take common. And in the bracket we will be left with a square plus b square. Now this cos square alpha plus sin square alpha and this sin square alpha plus cos square alpha will become 1. So it will be written as a square plus b square plus 2 cos alpha sin alpha into a square plus b square. Now what we can do, we can again take this a square plus b square as common. And we will be left with 1 plus 2 cos alpha sin alpha. So this is the final thing which we can write. And since you are in 10th class, you are not aware with the different formulas of trigonometry, so you can leave your answer up to here. But you for when you will go in the 11th class, and you will know that 2 cos alpha sin alpha is also known as sin 2 alpha. But no need to do this one now because this is not in your syllabus. So till this point you can leave your answer. Sonu, is this clear? No. You can't take a square plus b square out of the root because there is no whole square on a square plus b square. It will remain inside the root as it is. If there was whole square on the a square plus b square, then only we can take out of it. We can't, right now we can't take. Like if we have something like this, a square plus b square whole square, then it is only a square when we can take. Otherwise we can't. So in this one it will be remain as it is. Okay, Senapati, the back side. Are you getting this, Senapati, also? Itanagar, on the previous question or on this coordinate question? Okay. Shillong, in the second last step, the 2a square plus b square, but there is not whole square on that a square plus b square. This one, Itanagar? Shillong, in the last step, 2a square and b square are there. We can take only that common. Since there is no whole square on that one, we can't take that one outside the root. Is this clear? Sonu, Shillong, is this clear? And Itanagar, the answer which you have given for that question, triangle, that is correct. Shillong, is this question clear? The coordinate one? Okay, that's great. Now let's move on to our this question which we were doing this question. So most of you have given the answer as 25:16. You have just squared the ratio, but that will not work over here because this is the ratio of this AD and this DB, and we are looking for this DEF and this CFB. Now if you look closely, I'm giving you the hint. The DE is parallel to BC. It means this angle and this angle. And similarly, this angle and this angle. These two are similar, right? So we just have to find, we can say that triangle ADE is similar to triangle ABC. We have done so many times this result. ADE is similar to ABC because DE is parallel to BC. Corresponding angles are equal. So we can say that AD over AB, that is equal to DE over BC, the ratio of the corresponding side. Now this AD over DB, we can see that AB, this complete AB is made up of AD plus DB. So we can write AB as AD plus DB, and that is DE over BC. So AD is 5 and AD plus DB, that is 5 plus 4, and that is equal to DE over BC. So it implies DE over BC is equal to 5 over 9. This is the ratio. Now we can take the triangle DEF and triangle CFB. So now you can see that these two triangle DEF and BFC, these two triangles will also be similar because since DE is parallel, so it means this angle is equal to this angle alternate, and these two are all vertically opposite angle. So we can say triangle DEC is parallel to, similar to, triangle DEC is similar to it is DEF. Triangle DEF is similar to triangle CFB. So now we can say that area of DEF over area of CFB is nothing but the ratio of square of the ratio of corresponding sides. So that would be equal to DE over BC whole square, and DE over BC whole square, which is 25 over 81. This is the final answer. All of you are getting this? Is this clear to all of you? Okay. Now try this question. So that in this question the diagram is given. This is the diagram. It says This is a board question. This is triangle ABC, and this XY you can see. It says that XY is parallel to AC. And one important point is XY divides triangle ABC into two parts of equal area. It is dividing ABC into two parts of equal area. So now you have to find AX over AB, the ratio of AX over AB. So into two parts of equal area means area of triangle BXY is equal to area of this quadrilateral XAYC. And this is an important question. Mark this question as important. A star mark. No, Itanagar, the answer is in root. Some radical terms will be there. See, so let us solve this question. It's a good one. It is given that XY divides triangle ABC into two parts of equal area. So the area for this region is equal to area for this region, right? So we can say the area of triangle ABC, the larger one, is made up of the area of these two, is equal to area of triangle BXY plus area of AXYC, and we know these two are equal. So we can write this one as twice of area of BXY, which is area of triangle ABC. So area of triangle ABC, that is equal to twice of BXY. This is the thing we know. Now, and we also know that XY is parallel to AC, so we know that these two triangles are going to be similar. Because if this is parallel, so it means this angle is equal to this angle corresponding, and angle B is common to both the triangle. So we can also say triangle BXY is similar to triangle BAC. So after getting these two triangles as similar, we can relate the area with the side. So we can say that area of BAC upon area of triangle BXY. And now we have to relate it with the side. We want what we have to find over here. We want AX and AB in our answer. So this is AX and this is AB in our answer. So we will take these side. So what we can do, so the ratio of, since these are ratio of area would be the ratio square of the ratio of corresponding side. So we can take from the triangle ABC, we can take AB as the side and BX as the side. So AB over BX whole square. This is the relationship which we can write from the concept of similarity. The area would be equal to the square of the ratio of corresponding side. Now, what about from this relation, triangle AB, area of triangle ABC is twice of BXY. So we can write this area of ABC as twice of BXY. So ABC upon BXY, we can simply write this one as 2 and AB over BX. But what we have to find AX over AB. So we want AB, but we don't want BX. So what we can do, we can replace this BX, because we know that AB is made up of two things, AX plus BX. So we can write BX as AB minus AX. So we can write this BX as AB minus AX and whole square. This is the thing which we can write. Now we in our the formula which we are getting only AB and AX. So we just have to rearrange it to get the ratio of AB over AX. So just what we can do over here, we can take the square root on the left hand side. So it will become root 2 is equal to AB over AB minus AX. Now we can do the cross multiplication. So root 2 AB minus root 2 AX is equal to AB, right? Now what we can do, we can take this AB on the left hand side and root 2 AX on the right hand side. So we can take it like this. Root 2 AB plus minus AB is equal to root 2 AX. We can take AB as common. So root 2 minus 1 is equal to root 2 AX. Now AB over AX. So we want to find AX over AB. So AX over AB, this is root 2 minus 1 over root 2. This is the relationship. This is the relation. All of you are getting it? Is this clear to all of you? Shillong, Itanagar. Last paragraph. See, last paragraph is nothing but, you can see, till now is it clear that the area of triangle ABC is twice of area of BXY? And after this, what we have done? Okay, after this relationship, area of the similar triangle is equal to the ratio of square of the ratio of corresponding sides. Now what I have done after this, first of all I have looked to what we have to find. I want AX and AB in our answer, and we know that AB is nothing but AX plus BX, and in this area we are getting BX. We don't want BX in our calculation, so I have just replaced BX with the help of that relation. AB is equal to AX plus BX. So I have written BX as AB minus AX. That is the thing which I have done. So you can see. So BX I have written as AB minus AX, and this AB as it is. After this, I have taken the square root on both the sides, so this will become root 2 and this will become AB over AB minus AX. Now just do the cross multiplication. So when we do the cross multiplication, this root 2ab minus root 2ax, that is equal to ab. Take this ab on the left hand side and root 2ax on the right hand side. We'll get something like this. Take ab as common. So we'll get root 2 minus 1 in the bracket is equal to root 2ax. Now ax over ab. So root 2 minus 1 over root 2. This is the final answer. Is this clear, Kohima, now? A little bit different approach in this one. Although the concept is same, ratio area of similar triangle is equal to the square of the ratio of corresponding side. That's great. Kar lo copy. So now in this chapter only one concept is left, that is the Pythagoras theorem. You all know what is Pythagoras theorem. So what we will do, we will try to prove the Pythagoras theorem by the concept of similarity, and after that some more relations on the Pythagoras theorem is there. So this is the only concept left in this one. So that one we will do in the next class. So before the next class, all of you try to solve all the questions from your textbook till Pythagoras theorem, like area, concept of area, and whatever concept we have done so far. Try to solve all the questions from your textbook, and you can do up to Pythagoras theorem. The Pythagoras theorem part we will do in the next class. Okay, so that's all for today. So we'll meet in the next class then. Okay then, thank you, bye.